Hi everyone. Today we're going to look at our last type of transformation, and it's rotations. And I think rotations are probably, at least for me, the trickiest because they require some visualizations. But the good news is that by doing this online, we can look at this in a different kind of way than if we were in class. So let's look at what a rotation is first of all. A rotation is a transformation that turns a figure about a fixed point. Turns a figure around a fixed point. So for example, if I take this shape right here and I have a fixed point right here in the center, what that's going to do is if I turn this point, or if I take this image, oh, my point went away, it's going to rotate this around that point. And so the center of rotation is that fixed point that a figure is rotated about. And then rotational symmetry is that if a figure can be rotated 180 degrees or less and match the original figure, it has rotational symmetry. So for example, oops, let's move that one back. Okay, so it started here. But 180 degrees is half of a circle. So it would be like that. So if I can move this 180 degrees or less, then I can say that it has rotational symmetry. So I'm rotating. I haven't gotten back to my original shape yet. And right there, I can see that this right here is my starting point. It's what started out up here and now it's over here. I'm actually back where I started. And this is less than 180 degrees. It's actually 90 degrees. But we can see that because I can rotate this even 180 degrees, oops, and 180 degrees and be able to still get back to the original shape and the position, it has rotational symmetry. Similarly, this one, if I rotate this, and it doesn't matter if I rotate clockwise or counterclockwise. Oops. So I'm rotating, there's 90 degrees. Hey, that's less than 180, right? That hasn't gone a full circle, or full half circle, excuse me. But it has gotten back to its original shape. So this is rotational symmetry. All right, so the angle of rotation, we say that if a figure has rotational symmetry, that the angle measure, or the degrees that it rotates, is the angle of rotation. And as we said before, how many degrees are in a full rotation? 360 degrees. We've learned that when we were dealing with circles. So, do the following shapes have rotational symmetry? And if so, find the angle of rotation. So these are the same shapes that we were looking at, the first two are at least. And we said, okay, if I rotate this like that, and actually I can see the overlay, that it overlaps and it is the same shape, I have rotational symmetry. And so how much did I have to rotate it in order to get the, in order to get back to the shape? Well, I'm thinking about it this way, that there are three like I rotated a third, excuse me, I couldn't think of the word. I rotated it a third of the way around the circle. So I'm going to say, okay, there's 360 degrees in a rotation. Divide that by 3, and that would give me 120 degrees. So the angle of rotation is 120 degrees because that's how much I rotate it before I get back to the original shape. With the second one, I'm going to rotate. It hasn't gotten back to its original. When all the lines line up, there we go. They line up. So that is the rotation. Now we said that we could rotate it 180, but really I can stop before that. I can stop a fourth of the way, and that means that I'm saying, okay, 360 divided by 4 is 90. That's another way that I can get that 90-degree angle. I can say how far around the circle do I have to go before I rotate it. Or the other way to think of it is, how many times as I'm rotating does it line up to the original shape? Once, twice, 3 times, 4 times. I can rotate it 4 times before and have it line up. So that's another way to get that number 4. So think about this one. If I rotate it, I want to see how many times do I have to rotate it before it lines up with the original figure. This one, I didn't crop it perfectly, but there's 1, there's 2, 3, 4, and 5. The reason that one didn't work out perfectly is because that the center of rotation is actually a little bit below the center. The image, the way it cropped, it's not rotating correctly. But this has 5 places or 5 positions that it can rotate and still be the same thing. So 360 divided by 5 is going to give me 72. So the angle of rotation is 72 degrees. All right, so this says draw the image after a 180 degree rotation about point M. So in other words, I'm saying point M is going to stay the same, and I'm going to pick up this triangle and I'm going to rotate it. Now, using the rotate feature here won't work because it's rotating the whole thing. So I'm going to have to kind of think outside the box. I'm saying, okay, this point is not moving. I'm keeping point M fixed in that spot. Now L is going to get moved 180 degrees. So I need to move this point. Actually, let me do it this way. I'm going to put a little circle on L, and I'm going to drag it. So I'm thinking about if it travels 180 degrees around, it would go down here. But it doesn't say that we act like I would go a little bit off the graph. I'm going to draw it over here to this side and say that if we rotate it around point M, and no, I'll go ahead and put it down here and just kind of say it's a little bit shorter than what we wanted. That would be point M, or point L. For N, if I rotated 180 degrees, it's going to go like that. Remember, another way to think of it is that 180 degrees is a straight line. And so you can remember we talked about lines like this, and what's that angle? That's 180 degrees. So you can say, okay, I need to go 180 degrees around this point. Well, that would be right here. So I'm going to put 1 point here, and that's going to be N prime. I'm going to have L needs to go 180 degrees around M. Well, think about extending that line. And it's going to go 180 degrees around there. So see, it is going to go off my graph just a little bit, but we'll do our best. We'll kind of fudge it a little bit. And so that's going to be point L. Now, actually, that should be more like over here because it does still need to make a 90-degree angle with N. And when I sketch this triangle, it's going to look like this. Obviously, like it should end up looking, nope, that's not a good spot to do that. It should look more like this, but I don't have room to draw that down here. All right, draw the image after a 90-degree rotation about point N. And they didn't say if they wanted clockwise or counterclockwise. I'm going to say let's do counterclockwise. Oops. Just because I'll have a little bit better space for that. But we could do a clockwise rotation as well. So counterclockwise means that I'm going that way, the opposite direction that a clock's hands move. And so this time point N is staying put. Point N is staying where it is. Now 90 degrees is moving 1/4 of the way about a circle. So there are many different ways that you can think about this, but another way to think about it is, oh, that's not your homework. There we go. Another way to think about it is I can think about this being on a circle. Actually, let me just do this. Let me move everything up. Oh. Okay, I just paused it so I can move that triangle. The other way we can think about it is that there's a circle with N at the center, because that's the one that we're keeping fixed. And we're moving point L 90 degrees around the circle. So we're going to move L 90 degrees to right here. Okay. Now, if I want to move point M 90 degrees counterclockwise, I am going to do this. It's just kind of this is a really rough estimate. I would be able to do this part better in person. Yeah, that looks good. And so then I'm going to move point M 90 degrees around the circle, and it would go right here, M prime. And so I'm going to get rid of, or just kind of move that circle out of the way, and then I'm going to draw my triangle. Oh, my point went away. And it's going to look like this. So notice that this height is not the same, but that's okay because it's NM is not the same as LM. They're actually, LM is a little bit longer. So I've shown you like 3 different ways to kind of think about it. What way is working best for you? You try and see which way works best. First of all, though, remember 270 degrees. How far around the circle is that? That's 3/4 of the way. So if this is my circle, 270 degrees would be saying if I start here, it's going, that's 90, 180, and this is 270, going 3/4 of the way around the circle. All right, so this is kind of a sketch of what it should look like. You can see I took point L, and this is obviously not a perfect circle. I kind of squished it so that it would fit here, but I brought it around here and said, okay, point L would end up over here. Point M would go through 90, 180, and get to 270 degrees, and it would end up here. So, like I said, this lesson, it's either going to come really naturally or you're going to be like me and you have to kind of work at it a little bit. But the good news is, if you have questions, I am available to help. So check out Google Classroom to see what your assignment is. Some problems will be problems like this, where you're telling me, is there rotational symmetry? And if so, find the rotation angle of rotation. And some of them will look more like these, where you're having to use Google Drawings to rotate an image around a certain point. But they will look similar to this problem. I will keep it to the 4, or well, I guess 3 technically, main degrees, 90, 180, 270, and I won't get really weird and say like, rotate this 82 degrees. I'll give you nice, easy angles to work with. Let me know if you have any questions.